Hello. For day number 8, we're going to take a look at how to find the lengths of segments of when secants intersect outside of a circle. So if we take a look at, let's say these two secants intersect at point P, A, B, C, and D. So this formula is a little bit tricky. It's actually going to be the length of the outside segment times the length of the whole segment is equal to the length of the outside segment for this piece times the length of the whole segment. So it's using this diagram, it would look like BP times AP is equal to CP times GP. So again, it's the length of the exterior times the length of the whole segment is equal to the length of the other segment exterior times the length of the whole segment. So let's take a look at this example. So find RS if PQ is 12, QR is 2, and TS is 3. So we're trying to find the length of Rx, so I'm just going to label that as X. So if we follow our formula, we know that it's going to be the length of the outside, so QR times the length of the whole segment, which is RP, is going to be equal to the outside of this segment, which is RS, times the whole segment, which is RT. So QR is 2 times the length of the whole segment, so that's going to be 2 plus 12 is equal to the outside segment, which is X, times the length of the whole segment, which would be X plus 3. So we really want to be careful and make sure we're actually doing the whole segment in this inside. So if this is the same as 2 times 2 plus 12, which is 14, is equal to, distribute the x, we're going to get x squared plus 3x, or 2 times 14 is 28, x squared plus 3x. Again, we're going to have to use factoring. So I'm going to get everything over to one side, so we're going to get x squared plus 3x minus 28 equals 0. So let's look for our product sum. We have, the product is going to be A times C, so product is going to be negative 28. Our sum should be B, which is 3. So I need factors of negative 28 to get to 3. So to get a negative number, I know I'm going to have a negative and a positive number. Right off the top of my head, I think of 7 and 4. We need a positive 3, so I'm going to have a positive 7 and a negative 4. So I'm going to rewrite this in terms of my two factors. So I'm going to have x squared minus 4x plus 7x minus 28. I'm going to look at these two factors and these two and factor out a greatest common factor. Between x and negative 4, I'm going to have an x times x minus 4 plus 28 and 7, greatest factor is 7. So 7 times x minus 4. X minus 4 is matched, so I'm going to end up with x minus 4 times what's left, which is x plus 7. So I'm going to get x equals 4 and x equals negative 7. Well, I can't have a negative length for a line segment, so x equals 7 is out. So that makes the length of RS equal to 4. So again, factoring comes into play here. So let's take a look at what happens if it's a secant and a tangent that intersect outside of a circle. So if it's a secant and a tangent that intersect outside of the circle, it's going to be pretty much the same thing, but it's going to be a little bit different. Since we only have one other point instead of two where it intersects. So let's say it intersects at point P. This is A, B, and C. So when this happens, we're going to get the length of the tangent squared is going to be equal to the exterior piece of the secant times the whole piece. So in this case, it would be CP squared would be equal to BP times AP. So let's look at an example. So find x. Assume that the segments that appear to be tangent are tangent. Okay, so this is again using the tangent formula. So we know we're going to have the length of the tangent squared is going to be equal to the length of the exterior of the secant times the whole secant. So I'm going to get the length of AB squared is going to be equal to CB times BD. So that's going to be 4 squared is equal to CB, which is x, times, so we really want to be careful here because it's going to be times this whole thing. So it's going to be times x plus 2. Because the length of BC is x and CD is x plus 2. We're going to get 16 is equal to x times 2x plus 2, or 16 is equal to 2x squared plus 2x. Looks like we're going to have to factor again here. So I'm going to get everything over to one side. 2x squared plus 2x minus 16 is equal to 0. Now, as I'm going through my product sum, I'm going to need a product. I'm going to need a product of A times C, so a product of negative 32, and a sum of B, which is 2. I'm going through my products. I can't think of any. So when that happens, we're going to have to get out our trusty old quadratic formula. Our quadratic formula is going to be negative b plus or minus the square root b squared minus 4ac all over 2a. So we go ahead and substitute in our values. Negative b would be negative 2 plus or minus the square root 2 squared minus 4 times a, which is 2, times c, negative 16, all over 2 times 2. Well, so next, keep solving it through. Negative 2 plus or minus the square root of 2 squared, which is 4. Our two negatives here is going to make us a positive since we're multiplying. So it's going to be 2 times 16, which is 32, times 4. We're going to get plus 128 all over 4. Now again, this is plus or minus here, so we're going to get two different answers for x. So we have that x is either equal to negative 2 plus the square root of 132 all over 4, or that x is equal to negative 2 minus the square root of 132 all over 4. So square root of 132 is going to come out evenly, so I'm going to go ahead and convert that to a decimal. So we're going to get negative 2 plus 11.49 all over 4. So we're going to get x equals 2.37, or we're going to get negative 2 minus 11.49 all over 4. So we're also going to get x equals negative 3.37. Well, once again, sorry about that, negative 3.37. So once again, we can't have a negative length. We know CB is going to be x. So negative 3.37 is out. So x equals 2.37 is going to be our answer. Okay, So for the rest of the problems in this packet, there's only going to be 2 other questions where you're going to need the quadratic formula to solve the problem. The rest of them will factor nice and neatly. So there's only going to be 2 problems where you're going to have to worry about using the quadratic formula for the rest of day 8. So that's going to be it for your video for today. Thank you.